Myself, Dr. Viswanath Allamraju, Institute of Aeronautical Engineering, Department of Mechanical Engineering, Dundigal, Hyderabad. In this session, we are going to study the definition and terminology of velocity and acceleration diagrams. So, what is velocity? It is the rate of change of displacement is known as velocity. Suppose it is S is the displacement, then velocity V equal to ds by dt. And the rate of change of velocity is known as acceleration, that is dv by dt. So then substitute in the place of v ds by dt, then it becomes d square s by dt square. That is acceleration. The acceleration is rate of change of velocity, and the velocity is the rate of change of displacement. And here, what is very important term in this case of drawing the velocity and acceleration diagrams, what is absolute velocity and what is relative velocity, and what is absolute motion. So the motion of a body in relation to other body which is at rest or to a fixed point located on this body is known as absolute motion. So it is the relative motion relative to another body. The motion of a body in relation to another body which is at rest or to a fixed point, then it is known as absolute motion. Now here, absolute motion, in order to understand the absolute motion, let us take an example. When the person is moving in aeroplane, or when the person is traveling by train or traveling by bus, okay, it is under motion. The person is traveling. When the bus, the velocity of a bus with respect to the ground, that velocity is the absolute velocity or absolute motion of that bus. But whereas the velocity, if the person is moving inside, the bus is walking, is having certain speed while walking. What is the velocity of the passenger P? The velocity of the passenger with respect to bus, okay. And suppose if you want to know the velocity of the passenger with respect to ground, that is VPG. Velocity of the passenger with respect to ground, VPG equal to velocity of the passenger with respect to bus plus velocity of the bus with respect to the ground. The velocity of the passenger with respect to ground is known as the absolute velocity. The velocity of passenger with respect to bus is known as the relative velocity. And velocity of the bus with respect to ground is the absolute velocity of the bus. It is absolute velocity of the bus. But here the velocity of the passenger with respect to bus is known as relative velocity. Now here, and velocity of the passenger with respect to ground is the absolute. Point is that the velocity, absolute velocity also relative velocity, but with respect to the ground. And relative velocity is not with respect to ground, with respect to the immediate, whatever traveling is by. That is one of the example. If you want to understand the further what is absolute motion, what is relative motion, What is absolute motion and relative motion? If the person is traveling in a train, if the person is traveling in a train, is moving in a train, the velocity of the train, the velocity of the train is the passenger and is the train is moving. Okay, whatever, make it. If the person is traveling in a train, person is the passenger P. It is a train journey. Okay. The velocity of the train and passenger P. The velocity of the train with respect to ground VTG, that is absolute velocity. The velocity of the passenger in the train, if it is moving, that is the relative velocity. Suppose if you want to know the velocity of the passenger with respect to the ground VPG, that equal to velocity of the passenger inside the train plus velocity of the train with respect to ground. Now this velocity of the passenger with respect to ground, generally it is denoted by absolute velocity is Vp. That means Vp is the absolute velocity. The default it is with respect to the fixed body. And velocity of the passenger with respect to time Vpt, passenger with respect to time is the relative velocity. And velocity of the train with respect to ground Vt or Vtg. But generally we simply mention it as Vt. Velocity of the train with respect to ground. So there are two absolute velocities, passenger with respect to ground and a train with respect to ground. But there is a relative motion, that relative motion Vpt equal to velocity of P minus velocity of the T. This is the relative velocity. So this is the concept of understanding what is relative velocity, what is absolute velocity. While drawing the acceleration diagrams or velocity diagrams, we have to write down the velocity equations and acceleration equations. Then after writing down the velocity and acceleration diagrams, from those diagrams we have to write down the vector equations. From the vector equations, we can know the directions of each point on the link such a way that we can calculate the velocities and accelerations of various links of a mechanism. Suppose if a slider crank mechanism is there, this is a slider crank mechanism. This is point A and it is B, it is C and the slider D. If you want to find out the velocity Vb, velocity of B with respect to a fixed link, that is absolute velocity. It is denoted by small letters, velocity B with respect to A, that is A is the fixed link. This is absolute velocity. And whereas velocity of D or velocity of C, B, it is the relative velocity, VCB. Velocity of C with respect to B is the relative velocity. This velocity is absolute and it is relative. And again, velocity of C with respect to fixed link, that is VC, absolute. Now if you want to find out the velocity of the D, Vd, that means that is equal to with respect to fixed link. Velocity of D means with respect to fixed link. That is velocity of D with respect to C, or velocity of D we want with respect to VDO. Velocity of D with respect to C we have to calculate. Then only we can calculate the absolute motion, absolute velocity with respect to fixed link. Now here, the method to find out this velocity, the values of velocities of various links by graphical method, or it is also known as relative velocity method. Relative velocity method. In the relative velocity method, we'll use the vector equations and draw the line diagram, velocity diagrams. Thus, we'll calculate the velocities of various links. As I explained more here, what is relative motion? The relative motion is nothing but the motion of a relative body with respect to another body is the relative motion. And describe the concept of velocity analysis. The velocity analysis means, in simply, we can say that we have to calculate the velocities of various links of a mechanism by using relative velocity methods, and equations of velocity is known as the velocity analysis. Now, as dynamic forces are a function of acceleration, and acceleration is a function of velocities, and velocities is a function of displacements. So the study of velocity and acceleration will be useful in design of mechanisms of a machine. So the mechanism will be represented by a line diagram that is known as kinematic diagram or configuration diagram. The mechanism, the complete mechanism will be represented in a diagram. In order to do the velocity analysis or kinematic analysis, the diagram is known as a configuration diagram. So this analysis can be carried out both by graphical method as well as analytical method. This complete concept is known as a phenomenon or is known as the velocity analysis. It is not a phenomenon. The complete procedure comes under the category of velocity analysis. In the velocity analysis, first we will draw the line diagram or configuration diagram of a mechanism. Then after that we use the method. There are two types of methods are there, either analytical method or graphical method. That graphical method we can use by using relative velocity method. We will find out the unknown velocities and accelerations or velocities of mechanism, velocities of links of a mechanism. That procedure is known as a velocity analysis. Next, describe the concept of acceleration analysis. What is the concept of acceleration analysis? The concept of acceleration analysis, that again, first step, we will draw the configuration diagram. Configuration diagram. In the configuration diagram, from the configuration diagram, we'll apply the concepts of velocity equations. Velocity equations and draw the velocity diagram. By using velocity diagram, we'll find out all the velocities of links. Then, after calculating velocities of links, for drawing the acceleration diagram, we need two types of accelerations. One is tangential, another one is radial. Radial and AT. AR and AT we have to calculate. By using the method of graphics, that is graphical method, we will draw the acceleration diagram and find out the unknown values of unknown acceleration values of the remaining links. This complete procedure is known as the acceleration analysis. In this acceleration analysis, in one sentence, we will find out the accelerations of the links of a mechanism by using the relative acceleration diagram or relative method. We will find out the relative method. So, what is important? The prerequisite for acceleration diagram is velocity diagram. So, velocity diagram we have to draw. But whereas in velocity analysis, we no need to do acceleration analysis. We will do only direct velocity analysis. But for doing acceleration analysis, we have to do first velocity analysis, then we can go for the acceleration. Otherwise, it is not possible. Now, so for drawing the acceleration, for doing acceleration analysis, we need the velocity values of all the links. These velocity values are useful to find out the radial component of acceleration, that is v square by r. V is the velocity which comes from the velocity analysis, where r is the length of the link. By substituting in this formula, then we will get it, the radial acceleration. But what about tangential components? These tangential components comes from, by intersecting, which is this tangential component of acceleration is normal to the radial component in such a way that the methodology of the acceleration diagram will draw such a way that we can find out the values of tangential component of accelerations very easily. That procedure is known as acceleration analysis. Now, very simple question, what is the unit of velocity here? The unit of velocity is meter per second. Then what is the unit of acceleration? Meter per second square. Rate of change of velocity, meter per second, that is meter per second square. Next, what is linear velocity? Okay, the linear velocity formula here. What is the linear velocity? There are two types of velocities. One is the velocity during translation, that is a linear. The velocity during rotation, it is angular. Angular velocity, and another one is linear velocity. Okay, this linear velocity is the displacement by time. When the body is in moving straight line, that is linear. When the body is in moving circular direction, that is angular velocity. Linear velocity denoted by small letter v, angular velocity is omega. Then again, what is the angular velocity? Angular velocity equal to d theta by dt. That is rate of change of angular displacement. And angular acceleration alpha equal to d omega by dt. Rate of change of angular velocity is known as angular acceleration. Now this angular acceleration can also be written as d square theta by dt square. So, in order to find out the angular velocity, we need the angular displacement. Now, in the case of while drawing the velocity analysis and acceleration analysis, for acceleration analysis, what is the tangential acceleration? That is r alpha. This r alpha is what? D square theta by dt square. This is the acceleration, angular acceleration. Radial acceleration a r equal to v square by r. What is the total acceleration? Equal to at plus ar. Sum of tangential and radial component of acceleration is known as total acceleration. Now, what is important term is known as what is the components of Coriolis acceleration. Here, this the definition is wrong here. What is the relation between? And one more thing, this is also wrong. The linear velocity formula. The linear velocity, the relation between linear velocity and angular, that is v equal to r omega. That is the formula. So what is the angular velocity? That is radians per second. Similarly, the relation between linear and angular velocity, that is v equal to r omega. Where omega is angular velocity, r is the radius, that v is the linear. This is the relation between, formula of relationship between linear and angular velocity. Next, what are the components? What are the components of what are the components of Coriolis acceleration? So, in this Coriolis acceleration, that acceleration of a body, there are two components are there. Number one, first component is centripetal acceleration. And second component is the tangential acceleration. Centripetal and tangential acceleration. Now here, what is the formula for the Coriolis component of acceleration? So, in the Coriolis component of acceleration, that is AC equal to 2 times omega v. This is a unique formula. This omega is the angular velocity, v is the linear velocity. That means the component which is having Coriolis acceleration, that means it is having both angular and at the same time linear. It slides at the same time it moves circularly. That unique combination, combined angular and at the same time linear. So where it will be taking place, where it will occur? It will occur in the case of a slider crank. In the case of Whitworth quick return motion mechanism, where the slider, okay, whatever you're having, the bar, crank is here, it moves. The slider slides at the same time it rotates. Okay, the slider slides okay, cutting tool and all. The point is that here this slider, this is having the acceleration of that component. That slider is known as Coriolis component of acceleration. Coriolis component of acceleration or Coriolis acceleration. These are the definitions related to the velocity and acceleration diagrams, and it comes under the category of relative velocity method. Now, if you want to find out the velocity points of by using another method, that method is known as I-center method. What is the meaning of I? This I stands for instantaneous center. This is instantaneous center method. What is I-center? I-center means the link which rotates about another fixed link. That center is known as I-center. If we consider slider crank mechanism, there is a link 1 and it is link 2 and it is link 3 and link 4. The link 2 is rotating with respect to fixed link about a center. That center is known as I-center. This is I-center. 2 and 3 rotating about this joint, that is another I-center. 3 and 4, this is another I-center. But 4 is moving with respect to 1, not rotation. It is having a translatory motion. Where is the I-center? The I-center of a slider is at infinity. It is along a straight line anywhere. It is because it is infinity. That's why while calculating the velocities of links by using I-center method, especially for the case of slider crank mechanism, we have to transfer the I-center of slider. It is on anywhere in a straight line. We will transfer to here also at infinity. This 4 I-center. So the link 4 with 1, that is I-center 1 4. This I-14 here also anywhere on the straight line, because it is a translatory motion. Where it is, the radius of the straight line is infinity. Now, what is the formula? What is the full form? That is instantaneous center. What is the formula of I-center? If you want to find out the I-center, we need 2 links. That's why number of links combination 2. N into n minus 1 by 2. That is the number of I-centers n. where n is the number of links. If n equal to 4, then number of eye centers ni, number of eye center ni equal to 4 into 4 minus 1 by 2. For a 4-bar mechanism, the number of eye centers are 6. For 5-bar mechanism, the number of eye centers 5 into 4 by 2, that is 10. The number of eye centers for 5-bar mechanism, it is 10. If it is 4 links, then it is 6. We will calculate in that manner by using eye center method. Now, what are the types of eye centers? There are various types of eye centers are there. Number 1, fixed permanent eye centers. Number 2, fixed eye centers. Number 3, neither permanent nor fixed eye centers. There are 3 types of eye centers. Those eye centers I am going to explain by taking slider crane mechanism, so we can understand better. Link 1, 2, 3, 4. Now, how to find out what are the eye centers are first? The first eye centers, how to know what are the eye center are? Now, how to find out those, and there are 4 links are there in slider crane mechanism. 1, 2, 1, 3, 1, 4, 2, 3, 2, 4 and 3, 4. These are the eye centers list. Now, in that, link 2 is moving with respect to 1 about this. This is 1, 2 eye center. 2 and 3, 2, 3. 3 and 4, 3, 4. 3, 4 eye center. This is 2, 3 and it is 3, 4. And 4 and 1 is at infinity. I1, 4 is at infinity. Next, this 1, 3, 2, 4. How to get it? This 1, 3, 2, 4 will be obtained by using another diagram. We have to draw how to locate the unknown eye centers. This is link 1, 2. This is 1, 2, 2, 3, 4. Dots. All dots are represents the links, link numbers, and the joint represents eye center. 2, 3, 3, 4, 1, 4. Now unknown, that is 1, 3. This is 1, 3 eye center. 1 and 3 join. How to join 1, 3? According to eye centers inline theorem, 1, 2, 2, 3 extension. This is 1, 2 and 2, 3 extension. And next, another combination is that 1, 4. This is triangle 1, 3. How it comes 1, 3? 1, 2, 2, 3 straight line. This is 1, 2. And where is the 2, 3? Yes, this is the 2, 3. You draw a line, straight line. Next, 1, 4, 3, 4. This is 1, 4 and it is 3, 4. You extend this line. That intersection gives 1, 3 eye center. Next, 2, 4. This is the 2, 4. How it comes to 2, 4? According to instant eye centers inline theorem, 1, 4, 1, 2 extension. It is 1, 2. Where is 1, 4? 1, 2 and 1, 4. It is also 1, 4 we have to transmit. At infinity, no? Now 1, 2, 1, 4 extension. 1, 2, 1, 4. Next, this side triangle. We want 2, 4. Yes. 3, 4 and 2, 3 extension. This is 3, 4. And where is the 2, 3? This is 2, 3. You extend. This intersection gives 2, 4 eye center. So, in that manner, we will find out the unknown eye centers. And what is the eye center? What is the velocity of the point on a fixed link? It is 0. Similarly, what is the acceleration of a point on a fixed link? It is 0. What is the displacement of a body on a fixed link? It is 0. So, when displacement is 0, automatically velocity and acceleration are also 0 values. Now next, what is the full form of eye center? Yes, instantaneous center. Okay. Now one more thing. If the body is moving on a road, this is the eye center. The relative motion of this link with respect to fixed link, this is the contact. This is the eye center about which it rotates. It's the pointy contact, and also it is known as higher pair contact. Okay, in this session we have learned what are the definitions, important definitions related to the velocity and acceleration diagrams, especially for the cases of, for the methods of relative velocity method for doing velocity analysis, and also eye center method is used. It is also used for doing velocity analysis. Now again, the number of eye centers can be located, or the location of the eye centers, unknown eye centers. Now, what are the permanent and fixed eye centers? I did not describe it here. The eye centers 1, 2 and 1, 4 are fixed eye centers. Eye centers 1, 2, 1, 4 are fixed eye centers. Next, eye centers 2, 3 and 3, 4 are permanent eye centers. And the remaining eye centers 2, 4 and 1, 3, remaining eye centers 2, 4 and 1, 3 are neither fixed nor permanent eye centers. So for all eye centers, we can categorize under these three categories are fixed eye centers, permanent eye centers, and neither fixed nor permanent eye centers. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.